Hello and welcome to this new video. Today we are going to talk about Linux from Nothing Compiler Edition coming up. So yes, today we are talking about Linux from nothing, and we are going to install what's needed in order to compile things straight from the Linux from nothing install. Now we are going to need a lot of things. We are going to need to grow our partition, well, technically grow our disk and then transfer the stuff around. We are going to need the Linux headers. We are going to need a real version of Glibc and install GCC and install everything that make need in order to compile stuff. Now, let's just talk a little bit about why it's important to do that step. Why should we not continue to actually compile stuff from the host machine and throw them onto our LFN installation? Well, if you've been following this tutorial at home, maybe you've already run into the reason why this is a bad idea. Well, it's because it's a bypass. We're kind of just running around doing things and hoping that they work. Let me give you a little bit of background. When you compile stuff on Linux and on any OS in reality, you will have multiple steps of the compiling process that will actually look at your system and will try to make the best version for your system. So when the compiler compiles stuff, it doesn't only compile stuff, it actually looks at, oh, what do we have? Can I use this function? Can I actually integrate that library in order to get more out of the software that I have? And when it does that, well, it can have a lot of issues if you don't have that library onto the end system. So one big example of that would be the software curl. Curl is pretty much the most complex library intensive piece of software there is out there. If you look at how many libraries curl use on your system, you're going to probably die. It's insane, okay? There's no other software that needs or can take advantage of that many libraries. But at compile time, let's say that you have a very restricted system, it can actually be compiled with pretty much nothing. It really will just take the library that your system has and will try to take advantage of it. But this would be a big issue if we would compile, let's say, curl on our host system and throw it onto LFN. We would then have a bunch of libraries that are not there onto LFN that curl would try to look for in order to work correctly. So we will solve that issue by putting the compiler straight into LFN and compiling all our software directly onto LFN in order to completely stop that issue. Now, if you were wondering why Linux from scratch is boring, I'm sorry I'm saying it, but it's true, it's because they use a cross-compiler. Now, a cross-compiler is a great idea. What you want is to actually have a middle step where you will be compiling stuff for your Linux from scratch installation using a special compiler that will only have access to the libraries inside of your Linux from scratch install. Now this solves everything, but this also forces us to do a whole bunch of commands and not see the result. So that's the big boring part, but that's also an important part, right? So that's a lot of people have been asking question, what's the difference between Linux from nothing and Linux from scratch? Linux from scratch does things correctly. Linux from nothing does things for your ADHD, okay? It's there to be able to see result faster, but it may break a lot more because we don't have all the libraries that maybe your host system has, so we have some issues when we compile software. Now that that is explained, we can go through and start actually solving our issues by installing the compiler. And like I said a little bit earlier, the first place where we need to start is to actually have a bigger disk in order to compile all the source code that we need. So let's start by entering our LFN directory and let's mount our disk image that, well, it's a raw image, right? Because we have not created any special image for it. We just have created a file called disk.image and throw data onto it. It's not bad, but there is better ways of having data for our system. So that better way to have data will be QCOW2. QCOW2 is a disk format that will allow us to set a bigger amount of data to our disk without actually taking that place onto our real disk, because it will only take that place when it will actually be used onto the LFN install. It's going to make sense as we go. So once that we have created the loopback device for our disk image, let's mount that loopback device onto /mount, and let's create a /mount2 directory. With that directory now created, let's actually enable what will allow us to mount our QCOW2 image. Sudo mudprob nbd maxpart8. Now maxpart can be pretty much any number because we only have one partition, but put 8, it's way simpler that way. NBD is the subsystem that we will use in order to mount our disk image. Now let's create that disk image using QEMU-image create-f QCOW2, which is the format, disk2.image, and let's put the size of our disk, which I want it to be 100 gig. Like I said, you can put pretty much the value that you want in there, because in reality, it won't take 100 gig on your real drive because it's not been set yet, right? If we write 100 gig onto the disk2 image, well, it will actually contain 100 gig, but before that, it will contain only the amount of data that we write on it. Now, once that's done, we can do sudo qemu-nbd-c /dev/nbd0, which is our new loopback device, you could call it, disk2 image. Now we have set the kind of loopback device using nbd, which is name /dev/nbd0, and we will now be able to actually format it in order to have a usable drive. Now I'm just going to address a few questions that you may have if you're following along carefully. Some people know, if you have experience with QEMU-image, you know that you can convert raw disk into QCOW2 image, and that I could have resized the partition. The reason why I'm not doing that is because for some reason, when I'm using NBD while doing that, it pretty much does corruption all over the place. I don't know why, I couldn't tell you. It could be only my system, or I could be just walking into a bug. It doesn't really matter to me. What matters is the best solution is to do the same thing that we would need to do if we would want to transfer our disk onto a real physical disk. So right now we're pretty much doing the exact same thing that we would need to do if we would want to transfer this onto real hardware. So now let's do sudo fdisk /dev nbd0, and let's actually format a partition just like we did with our disk at the first tutorial. Now we can actually format the partition using ext4, and we can mount it to /mount2. And once we did that, we can transfer all the data from /mount, which is our original disk, and transfer it to /mount2, which is our new disk. Now, once that's done, we need to reinstall grub, because grub doesn't transfer itself just because we transfer the data that was into the partition. We still need to transfer, well, recreate the data inside of the bootloader. So for that, we use the same grub install command, just changing the root directory, which is /mount2, and changing the bootloader, which is /dev/nbd0. Once that's done, we can unmount /mount and /mount2 and actually just mount our new disk nbd0p1 onto /mount so we can manipulate it like we did before. Now once that's done, we now have a way bigger hard drive that we can use in order to start compiling stuff. So let's get onto that process and let's actually transfer the Linux headers. The Linux headers are a bunch of headers that are there to be able to link whatever software that you're using with the Linux kernel. So the Linux kernel has a bunch of functions, and in order to use them, it needs to be able to communicate with your C program, and the way that it does that is through those headers. So let's actually go inside of Linux. Let's do cd Linux. Let's do make headers in order for the Linux kernel to generate those headers, and then use sudo cp-r in order to transfer all the headers that are inside of usr/include and transfer them inside of /mount usr-include in order to get them into LFN. Once that's done, we can back out of there and we can go and start recompiling glibc. Now, we have already compiled glibc once, but we are going to do it again. The big reason why is that using a Git version is a little bit suicidal because you want the most important library inside of your system to be a real version. You don't want it to be a dev version. So let's actually use the most cutting edge version, but not the def edge version. Let's say it that way. So let's remove our glibc-build that we already created, and let's download from GNU the latest version of glibc, which right now is 2.41. Once that's done, let's uncompress glibc, let's create our glibc-build, let's enter it, and let's create our configure command. Our configure command will have a couple of things that are a little bit odd. We will have the with header option. That's there to tell glibc to compile against the headers that we just installed inside of /mount/usr include. The reason why we want to do that is because glibc is a library that will communicate a lot with the kernel. And in those communication, it's good to have the most up-to-date information and the most optimized information. To be able to do that, we give it the literal perfect headers that we just installed inside of our LFN installation. So at compile time, it will look directly for what it needs and compile directly for the kernel that we have. Now we will also need the without SELinux option because of course we don't have it, and the libdir, which is /lib, and the prefix, which is /usr. After that's done, we can do make-j8, and we can do sudo make desdir /mount install in order to install it at the right place. And then we can back out of there using cd ... So now we have the base library that we need, and we now need to actually install GCC onto Linux from nothing. So to do that, let's start by downloading GCC, which the latest version is GCC 14.2.0. So let's download that, let's uncompress it, and let's enter GCC-14.2.0 in order to prepare the install a little bit. So we need to install a few little things with GCC, which we can do by doing the contrib download prerequisite script. When that's done, it will download everything needed in order to actually compile GCC. There's other way to actually link those prerequisites. Please just use the script. The script is way easier. You're going to save a lot of time. Don't try to do it yourself. Do the download prerequisite script, okay? Just believe me. After that, you can do cd ... to back out of there and create your GCC build, enter it, and now we can actually build our configure command. Now, our configure command will contain a bunch of options. It will contain the with glibc version 2.41 because we want to tell it which version we are using so that it can optimize itself for it. Now, if we were not to tell it, it would actually compile using the information of the host machine. And in our case, I'm using a standard Ubuntu, and Ubuntu, as of now, it's using the 2.39 version of glibc. So we would not have the same version. Would it work? Yes. Would it be optimal? No. So let's get ourselves a little bit of a head start here and give it the right version. We will disable multilib. Multilib is just a way that we could actually compile 32-bit using a GCC that was compiled for 64-bit. So we don't really want to compile 32-bit software. That's why we're disabling multilib. So that's done. After that, we do enable language, C and C++. GCC can actually compile a bunch of language, and we don't want all those language to be compilable on our system, right? We don't want 7 language. We only care about C and C++, so let's tell it that we only want those 2. We are also going to do disable bootstrap. Now, bootstrapping is something that is quite important for GCC. When GCC is being compiled, it will actually compile a compiler and then use that compiled compiler to compile a new optimized compiler, and in reality then compile another compiler and compare both compiler. Anyway, GCC is really insane, and the compiling process of GCC truly deserve a video in and of itself. But we're not there for that today. Disabling the bootstrap will mean that you will have way less wasted time in actually building your GCC, because when you don't disable the bootstrap, because you need to compile so many more versions of GCC, it will take you multiple times the time that it would take you if you disable the bootstrap. It actually yields less performance because there's a reason why we normally do the bootstrap, but in any case, I think that you probably value more your time than the small optimization, If you do not value your time and you have something else to do, you can absolutely remove that option, and by default it will enable the bootstrap and compile a better version of GCC for you, and that's probably the only option here that you could remove and that it would still work the same way. It's just that disabling the bootstrap will make things faster. So that's the only reason why it's there. Now we also need the prefix option that points to /usr to put things at the right place. Once that's done, we do our make-j8 in order to compile. It will take a long time. GCC is probably the most complex software right around the Linux kernel, if not more complex when you don't disable the bootstrap. So it takes a long time. Now, once that's done, we can do sudo make this dir /mount install in order to throw it at the right place and back out of there. Now let's just think a little bit at what we have. We have the Linux headers, which we will need to compile a bunch of software and needed in order to compile glibc. Now glibc is now installed, so we now have the libraries that we need in order to compile any software. We now also have gcc along with the lib standard C++ library that comes with gcc. So we now have everything to compile C and C++ onto LFN. All we need is the script that actually compile things onto our LFN. And those scripts, well, they're mostly make. So when you compile things, you use make. We use it throughout the 3 tutorials. We've used it today. Make is everywhere. So we need to install it onto our system in order to start compiling things. And we're going to run through a bunch of install because we need to install a bunch of things. So I'm not going to show all the commands. If you want to see all the commands one by one, go on to maplecircuit.dev. But we're going to talk about each command if there's something a little bit fancy about them. Now make, what is funny is that you need make in order to compile make. So yeah, that's kind of the egg and the chicken thing, right? We have that that issue here. So that's a big reason why we're compiling it now. I think that there's a way to bootstrap make and to compile it if you don't have make, but it's preferable to have make and just do it that way. So we install make like any software that we do using the configure -- prefix /usr, all standard stuff. Right after that, we are going to install, like I said, a bunch of small software that will be needed either with make or around make in order to make it work. The first one will be tar. So of course we want to uncompress a bunch of things. So let's install tar onto it. Tar, again, configure. We need to tell it to not use SELinux, so -- without SELinux, and prefix /usr. We finish that install like any other. After that, we install gzip. So gzip, of course, we will use with tar. So let's install that onto our system. Again, it's a configure -- prefix /usr. There's no need to tell it that we don't need SELinux. It doesn't care about that. After that, well, it's more software that may need, like sed. So sed is used extensively by make, so we need it. We compile it. That one we need to tell it that we don't have SELinux, so we do the -- without SELinux. After that, we need grep. Again, grep used extensively by make, so we need it. That one we don't need to tell it that we don't want SELinux. And after that we need awk. Now awk is used in some make script, but I mostly want to install awk right now because awk is that kind of software that a little bit like make, you need make to compile make. Well, you need awk to install awk. So let's install it right now. Let's skip that process. We install it. We don't need to tell it that it has SELinux. And now the last software of the day will be binutil. Now binutil is there because it contains ld and a bunch of other commands. So it contains a way for GCC or make to link our binaries to the libraries, which is the final step of compiling. So that's of course needed to be able to compile stuff on our system. So we will download it. Again, it's all a standard install. No need to tell it that we don't want SELinux. Now that the boring installing stuff is done, let's actually do something productive and make internet work correctly. In our last video, you saw at the end that we actually needed to tell the system that we didn't want to check the certificate in order to download something using wget. Now, the solution to that there's a lot of solution to that, but the simplest solution, let's say it that way, is to download a certificate from curl's nice people, because yes, they're always there to save our butt at the end of the day. So let's do wget, and with the curl URL, it will download the CA certificate that we should use in order to actually verify any HTTPS connection. And let's then create our directory that we need in order to put that certificate at the right place. On Linux, the standard place where the main CA certificate should be /etc/ssl/cert and have the name ca-certificates.crt. Now we are going to, of course, make the SSL directory, make the cert directory, and then move our ca-cert.pem and transfer it to ca-certificate.crt. So that way we have our certificate that's now put at the default place where it should be. Now it's not all the software that actually knows to look there for a certificate. Some will by default look there, but we can actually force most software to look there for their certificate. The way that we will do this is to export a variable inside of our init. So let's do sudo nano /mount sbin init in order to modify our init. And we are going to use the command export ssl_cert_file equals the address of our certificate. Doing that will force most software that uses HTTPS to know where the certificate is and actually process it correctly. So with that, we should have solved our issue with HTTPS. Now that's not the only thing that we're going to put inside of our init, because we have some issues that were created by the fact that we have a very, very simple system and a brand new compiler on it that was not compiled inside of the same machine. Because yes, what we are doing is kind of dirty, right? And we're not doing a perfect system. We should have compiled GCC out of a GCC that should be already onto LFN, but that's not what we did, so we need to kind of patch a little bit our system in order to make it work. The way we are going to do that is by using 3 variables. We are going to use compiler path, library path, and cpath. Compiler path will tell the compiler that it should look to those 2 directories in order to look for its executable. So when you execute GCC, you're not only executing GCC, you're actually executing also CC1 or other small executable that are part of GCC or even outside of GCC. One example of that would be LD. So we need to tell the compiler that it can actually look at these paths in order to get its programs. So compiler path is, hey, you can look there for your executable. Now we will also set library path. Library path is to tell the system, hey, you can look there in order to use your libraries. Now there is some internal libraries needed by GCC, so we pointed to the right place and now it can use them. cpath is there to tell it that it can use those header files. So the header files inside of the include folder made by GCC. Those are the standard compiler header file that are needed for a bunch of standard function. Now, let me put a little note. That's not all the directories that the compiler can look into. By default, the compiler will look into a bunch of directory. It's just that we need to kind of hack around because our compiler was not compiled from the system that it's now running on. It was compiled from our host, and it's now on our LFN. That transfer kind of breaks things around. That's why we have to do that in this hack. But in reality, the compiler already will look into /usr/lib for libraries. It will also look inside usr/include for header files. So it will already look at a bunch of places in order to get those information. We are just telling it for the things that it cannot find itself because we are hacking things around. Now let's save it and let's actually create a temp directory because we have not created it yet. So let's take care of that, right? We have some software that can actually need it. When we compile things also, it could need it. Now, normally we would want to mount a tempfs in order to flush it every time we reboot and have it inside of memory, but we don't care about that, okay? So for now, sudo make dir /mount/temp, that's going to be good enough. let's do sync a couple of times. Let's unmount/mount. Let's disconnect our /dev/nbd0. And let's now execute using QEMU our disk2 image. Now, QEMU is smart enough to know that it's a QCOW2 disk, so it won't die because of it. And for that, I would tell you that it's very important to use multiple cores now. So we have the -SMP, which tells QEMU to use more core. So -SMP8 because I have 8 cores, and we can do -M 8 gig because I want to give it 8 gig. It's really important there to give it more. The reason why is because we're compiling things inside of a VM environment. That's slow, very, very slow. And if you leave the default, you're not going to have enough space, or if you have, it's going to be even more slow. So you don't want that, right? So give it more memory, give it more core, so we can actually get that done as soon as possible. Now, once we have opened our LFN install, let's actually attempt to compile something just to be sure that we did everything correctly. Let's do xzutil. Now let's enter our root directory and let's download that xzutil using the 5.6.4 version. Let's uncompress that version. Let's do, as usual, a mkdir xz-build cd xz-build, and let's do a configure, which in our case should be simple. We don't have any special feature that we are asking xz to do. It will actually automatically detect everything because we're now on the right system. So we only need to do --prefix/usr. The reason why we still need to do that is because by default it will actually try to throw your program onto the local directory. So usr, local, and then /bin or /lib. We don't want that. We want it to be installed at the right place on our computer. That's why we need the prefix command still. Now we can do make-j8 and a simple make install, because we don't need to tell it to go somewhere else, right? We are right on the right system. So we do make install, and here we go. We have a working XZ. Now don't forget to sync, right? Because we need to crash out of our system. We don't have any way to shut down correctly, but remember to sync, all right? That's the most important part. Remember to sync before closing. But now we have XZ that actually works. So guys, how do you feel about it? Now we have a system that can actually compile things on its own. And because we have installed the basic amount of software that we need in order to compile other software, we should now be able to compile everything given enough time. Now again, if you want to mess around with the final result of this episode, everything's on the website. I always share the final version of the disk that we've created, so you're going to be able to download it online. Now it's the extra part, it's the extra part. Want to show that you're an absolute unit? Write XZ in the comments. So XZ is the secret code that shows that you're an absolute unit. Now, if you want to know a little bit where we're going with this, well, the next 2 videos should be something like curl and the Linux and making this work on real hardware. So both of those are going to be hella fun because, well, curl will allow us to get Git, and then with Git we should be able to download the latest version of Linux and then run our LFN straight out of our system and not out of QEMU, because QEMU is hella slow. So yes, that's probably where we're going. That may change, of course, you know how things goes. So I hope you enjoyed this video. If you did, of course, leave a like, leave a comment, and for now I can shill something. You can become a member. Yes, folks, you can now become a member. Oh, but Maple, what does it do that I become a member? Well, becoming a member will mean that you will get the video slightly faster, the between time that I actually finish the video and the time that I normally release the video, so you get it just a bit faster. And in reality, you push me towards making more video and maybe even making this my job, which would make you be able to watch way more of my content. So of course, be a member now. So that's all for the shilling for today. So of course, for now, take care.